Hello everyone, welcome back to my channel Chemical Education. Today I'll discuss about friction factor. Last video I derived Hagen-Poiseuille's equation for steady laminar flow of an incompressible fluid flowing through a circular pipe. So here this is the circular pipe and steady laminar of an incompressible Newtonian fluid is flowing through this circular pipe, and we apply Bernoulli's equation, that section 1.1 and section 1.2. So Bernoulli's equation is P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2 is equal to HF. So here P1 is pressure at section 1, V1 is the velocity of section 1, Z1 is the elevated height of section that 1.1. So if we take that is this center line as a datum line, so from here we can easily take that elevation height. P2 is the that pressure at that section 2.2, and V2 is the velocity at that section, average velocity of section 2.2, and here ZF is that frictional losses, and we know as that this is a horizontal pipe, so Z1 is equal to Z2, and as it is a steady flow, means V1 is equal to V2 is equal to V. So both side V1 square by 2g and V2 square by 2g will be cancelled out. This will be cancelled out, this will be cancelled out, and Z1 and Z2 will be cancelled out. So we have P1 by rho g is equal to P2 by rho g plus HF, and from here we got the equation del P by rho g is equal to HF. So last video I derived that, so derivation is already in the last video, so please have a look, I will know better. Now even also we know that average velocity, got this equation by doing force balance shear stress distribution, that V bar is equal to 1 by 8 mu minus dp by dl r square, and from here minus dp by dl is equal to 8 V bar mu by r square. Okay, and then so del p by del l means P2 minus P1 by del l, that is equal to 8 V bar mu r square. So a V bar is average velocity, mu is viscosity, r is the radius of the pipe, and from here we know P2 is nothing but P1 minus del P minus P1 by del L. So from here we got the del P by del L is equal to 8 V bar mu r square, and then del P we got that del P, that 8 V bar mu L by r square. Now if I convert that, if I plug r in terms of diameter of the pipe, so ultimately we got del P is equal to 32 V bar mu L by d square. Now if I write, if I want to get del P by rho g, so that will be nothing but 32 V bar mu L rho g d square. So that is nothing but and we also got that del P by rho g is equal to HF. So del P by rho g is equal to 32 V bar mu L rho g d square is equal to HF. So that is nothing but Hagen-Poiseuille's equation, and you know that above equation is only applicable for steady laminar and incompressible fluid flow. So this equation is applicable for only that steady laminar and incompressible fluid flow through a pipe. Now today I will talk about that friction factor. So we already got this equation. Okay, so we know this equation we already got, that del P by rho g, Hagen-Poiseuille's equation, 32 V bar mu L rho g by d square. Now here the beauty of this equation is, suppose if I want to calculate pressure drop, so if I know the average velocity and diameter of the pipe, viscosity and length of the pipe, we can easily calculate that del P. And from this equation we also can calculate that average velocity if we know that the pressure drop across that two section, so 1.1 and 2.2 section, if we know that del P, so we can easily calculate what will be the average velocity. Now we can also convert average velocity to volumetric flow rate. So average velocity is nothing but that V bar is equal to nothing but Q by pi r square, that is Q is a volumetric flow rate, and that pi r square. So now again, if I plug that r in terms of d, so we will get 4q by pi d square. If we know the average velocity, we can also calculate the volumetric flow rate. So q is a discharge through pipe, cross sectional area of the pipe, pi by 4 d square. Now we know the Hazen-Poiseuille's equation is nothing but del p by rho g is equal to 32 v bar mu l rho g d square is equal to hf. That is Hazen-Poiseuille's equation. From here we can replace v bar in terms of q here. So if I do that, so that will be del p by rho g 32 4q, just replace v bar in terms of the volumetric flow rate. So 32 dot into 4q dot mu l rho g d square into pi d square is equal to hf. So now ultimately, so here we will get that volumetric flow rate in terms of pressure drop as well as in terms of hf. So this is one equation. Okay, so the q we can get, so pi del p d to the power 4 128 mu l, means if we know the pressure drop, we can easily calculate volumetric flow rate. Even if another way, if I know that q volumetric flow rate, we can easily calculate what will be that pressure drop. Another way, we know, if we know the volumetric flow rate, another parameter, if we know diameter, density, g, mu l, we can easily calculate what will be the frictional losses, means hf, we can easily calculate. Now I will talk about friction factor. Now here friction factor, there are two friction factor generally widely used in that fluid mechanics. One is fanning friction factor, another is Darcy friction factor. So now here fanning friction factor can be expressed in terms of wall shear stress tau w and velocity head. Okay, so it is the ratio of the tau w by that velocity head, rho v square by 2. The relationship is derived from Darcy-Weisbach equation. So from here, if we means actually this relationship comes from this Darcy-Weisbach equation. So we can remember also that F is nothing but tau w rho v square by 2. And we also know that earlier derivation, force balance, when we do the force balance, we got this equation at r is equal to small r equal to capital R, we can write dp by dl plus 2 tau w by r is equal to 0. Now here we also know, that is from that Hazen-Poiseuille's equation, del p by rho g is equal to 32 v bar mu l rho g d square. So that we know from Hazen-Poiseuille's equation. Okay, and we also know in terms of that volumetric flow rate, we know the equation. Okay, now using that equation we will make some relationship with friction factor. Now here that friction factor is nothing but tau w by rho v square, and at r is equal to capital R, dp by dl plus 2 tau w I is r is equal to 0. Now here f is nothing but, so now if this is the f is equal to tau w by rho v square by 2. Now from here we will get 2 tau w rho v square, we will get, that means if that 2 will go here numerator, so that is 2 tau w rho v square. Now here dp by dl is nothing but 2 tau w r. So now we just replace 2 tau w, so f will be del p by del l is into r by rho v square. Now here if we change r in terms of capital D, so we will get f is nothing but del p d 2 del l rho v square. Okay, and we also know del p by rho g is nothing but hf, we got from that earlier slide. Okay, now here we can also write del p is equal to nothing but rho g into hf. Now if we plug that del p, so here we already know that f is equal to del p to del l d by rho v square. Now we plug this del p in terms of hf, so we will get rho g hf d to del l rho v square. Now here rho will be cancel out, and then now that will be cancel out. Now if I calculate hf, frictional losses, so that will be 2f del l v square d into g. Now if I reorganize, now here if we multiply 2, so that will be 4f, and then l del l or del l by d, that will be there, and v square by 2, because we are multiplying 2, so 2 will be denominator, so v square by 2g. So hf is equal to 4f l by d v square by 2. So that is the one equation, very popular equation. if we want to calculate frictional losses, so for that we should know this equation, means we need this equation. So 4F L by D V square by 2G. So now, so this is the fanning friction factor. This F is nothing but fanning friction factor. Fanning. Now another friction factor I told you, that is the Darcy friction factor. So that is nothing but 8 into tau W rho V square, means Darcy friction factor is nothing but 4F. So FD, that is Darcy friction, is equal to 4 of fanning friction factor. Remember that, this is very important. Now, so here if we got HF is equal to 4F L by D V square by 2. So 4F is nothing but the Darcy friction factor. So HF is equal to FD L by D V square by 2G. Okay, so this is the Darcy, this is fanning friction factor, and we also know the Hagen-Poiseuille's equation. Now from, if we know that from the Hagen-Poiseuille's equation, del P by rho G is equal to 32 V bar mu L rho G D square is equal to HF. Now this HF and this HF, if I equate, means here this term is equal to, is HF is nothing but 4F L by D V square by 2G. So if we do that, so we'll get new equation. So if we do that, then here, so V bar and V bar, one V will cancel out, so one V will be there, and L by D, so one L will be cancel out, so one V cancel out, so V bar will be there, and D and D cancel out, one D will be there. Okay, so now here 32 mu by, and GG will be cancel out. Okay, so here rho D is equal to 4F V by 2. Now if I take only F, if we multiply V2 and other things or here, so this will be 8. So now if we multiply, so that will be 16 mu rho dV is equal to F. Now, so here we know that RE is nothing but rho d V bar by mu. So now it is like a reciprocal. So 16 by RE is equal to F, or F is equal to 16 by RE. So we will get one relationship of friction factor with Reynolds number. So friction factor is nothing but 16 by RE. Remember, this equation is for laminar flow. Laminar flow means, in the laminar flow, if we know the laminar flow is flowing through pipe, so we can easily calculate the friction factor. So friction factor is nothing but, fanning friction factor is nothing but 60 by RE. Now what will be the FD? So Darcy friction factor will be 4F, so that is nothing by 64 by RE. Remember that. So fanning friction factor is nothing but 16 by RE, Darcy friction factor is nothing but 60 by RE. And keep in mind that friction factor is often determined empirically. Okay, it is sometimes we can't get experimentally. It is empirical value, and its value can be depend on that F is depend on Reynolds number. So F actually depends on depends on one Reynolds number, 2 is surface roughness, and third is flow condition. So now condition. Okay, so now we got that F is equal to 16 by RE. So that is fanning friction is equal to 16 by RE, and Darcy friction factor is nothing but 64 by RE. So now we know the relationship between the Reynolds number and friction factor. So I hope you have some idea about friction factor. That's it. Thank you.